Hey guys, welcome back. This is Peter and this is Tech Suvara, and today we're going to dig in a little bit into how to structure a renderer architecture, and in particular in reference to what we were doing last week with metal. So let's get straight into it. So in our previous discussion about metal as a system, the metal API is really just like a base. It's got like all these tools and bits and pieces that you can use for a number of different things. And one of the things that you can use it for, that it's probably used for the most, is actually as a renderer. So a renderer architecture consists of numerous parts. So it's not like you can just use metal and build a renderer straight away. You need to architect it and sort of plan out how the bits and pieces are all going to fit together. So today I'm going to jump on the iPad and we're going to talk a little bit about how one of many ways which you can structure a rendering pipeline, and the things that you would do. You would have the number of passes you would do. It's just a starter, so it's something that you could use to get yourself rolling in constructing a pipeline once you have this kind of architecture in place. So the idea would be to just get a fuzzy base idea of the structure and then sort of plan out how you would build it with the different parts. And as you go along, it's going to change, because what you know and what you learn will affect how you structure it. We want to try and minimize the impact. So you don't want to have so much upfront design that you kind of like are strictly based on what you designed upfront, especially if you're doing this for the first time. So you might do a few iterations. You'll have an experiment and then do a second one, a third one, and that's fine. That's how it works. And it also really depends on the kind of games you want to build. So if you want to build like a 2D top-down platforming collection of games and build your own rendering engine for that, it will look different than if you were to do a 3D rendering engine. And that's, I mean, they're essentially the same components, but in 3D you'd have additional things that you probably wouldn't do in 2D in terms of how you would do the projection mapping. But anyway, let's get straight into the design and how we would structure a renderer. Okay, let's go. Okay, guys. Basically, with this renderer, we'll start with a blank slate. I'm using GoodNotes here just to close these other ones here. Basically, brainstorm ideas on how to structure a renderer. Essentially, underneath it all, we know what we have, right? We have metal. We'll go through, kind of throw some ideas on paper, and we know what we want. We want to, draw. In this case, the end goal is, like, say, we want to do a 2D engine, something like, say, Unity 2D, and it just focuses on 2D. There's no 3D component, and we do want like maybe some way to be able to discern height. So we'll need something to be able to scale up and down, but generally all of our objects, they'll have an X and Y position, but they won't have a Z position. The camera will kind of like be always facing down, so the projection's quite, one-to-one. So what we want to do is we want to have our objects, right? So let's I'll put this on a stable surface so we can write properly. So we'll just scratch this out here for now. So we can, we'll scratch this out. So we know we have metal, and we know we have, say, our art assets. We have our world objects. And this is the high level, and in between here, we want to have our pipeline. Okay, so we want to have we know what we have. We know where we want to put it. So we have metal here, and this goes into the GPU. Well, yes, it's on the GPU, which goes out to the HDMI port or whatever it is. So screen. We have our world objects. We have our art assets. We have, what else do we have? We have, I guess, lights. We would have lights in 2D. Yeah, we could have lights. And we also have, the world objects, and we have our camera. All these things aren't really handled by metal. in the sense that we can have lights, but the projection and how they're rendered are all done in metal. So I guess the core thing is like we come in to our so this is our render pipeline, right? A render pipeline will come with some number of inputs, which will be a collection of these things, right? So it will come with the art assets, the world objects, lights, and camera. Now, essentially what it will do is we'll take all of this information and create stuff, commands, so that can be processed. So what it will output be, vertex coordinates, right? I will output render commands, and it'll also output, we will supply it with the shaders. And the render commands take the vertex coordinates and they essentially put them together to form what we would draw out via shaders, right? So the idea is that we would have the world objects get transformed into world space. So here, and then mapped with the art assets, right? So what do we need to do? We need to transform the world objects. We need to build our vertices, build vertices, and we will need to, I guess, we would need to, what else? Need to configure texture memory and shaders. Okay, so we're putting down on paper just essentially some basic ideas on how to structure what things exist in our pipeline. So these, although these aren't necessarily linked to the render pipeline, these are independent. We could have like an abstract renderer. Well, maybe I'll try to write that properly this time. Abstract render. So this is like abstraction. So basically, we could have anything at the high level that then transforms this information into something that metal is going to be more optimal in processing. Our art assets will essentially be 8-bit file. We can have 8-bit color file, 16-bit. We could do 16-bit, 32-bit. 32-bit be 888 alpha. 24-bit or 32-bit, depending on the texture. So we could use PNGs for that, but it's actually in general easier to use your own format that's just plain and simple, but we won't go into too much about that right now. World objects. So our world objects will have a center point. So we'd have world objects would have a center point. They'd have a rotation, depending on how we do this, whether we do objects rotated in along a center point or whether we don't necessarily rotate objects in 2D. But you would do that especially if you're not very often, but you would kind of have a rotation of the world object, and the center point would be somewhere in the world object. The world object, say for instance in this example, would have a center point. Center have a set of. It would be linked to art assets. It would be linked art, and it would be, I guess, the center point of the art assets would be a collection of, I guess, images or collection of objects, art assets. So world objects, say for instance, if it's a 2D object in the world, it may not necessarily be just one texture. For instance, if you've got a character that can have like interchangeable swords or shields, how would you construct that? You've got to think about that kind of stuff. So a world object might have a center point, but then have offset for different textures. And that would, we would directly link to this art asset. So when we go into the render pipeline, it will pull apart the world objects. Or what we could do is we could actually have like an intermediate step right here that would then take the art assets and build our render a texture map, right? Now, in this case, let me pass that in through here. So a texture map basically links all of the objects and vertices that we would render with something on the texture map, and we would only pull this texture map together from what exists in the art assets. Things like lights are pretty simple to define. We can have a light type, we'd have a type, we'd have a color, and also position. Right, so this would be structured in a way that would get fed into the render pipeline, and the lights would be probably placed early on. So we'd have like a lighting system that, step 1 would be to convert data to texture map. Step 2 would be configure the lights. Step 3 would be position the camera. And we needed to, once we have the camera, we would then transform all of the input coordinates of our textures by that camera position. The order of things is important, and a lot of it depends on the optimization strategy that you use, and things like that aren't always necessarily clear straight away. So, but yeah, guys, look, that's really just an introduction to rendering, and I think a little step forward. Understanding metal and doing this, putting something together, it's a huge undertaking and not something we can do in a couple of videos. But I hope this gives you good insight into some initial ideas on how to structure this. Okay, guys, thank you very much, and I'll see you at the next video. Bye. We are in the new studio, and my God, it's been a week. If I could, yeah, man, I should make a video about it on my personal channel. I think I will. It'd be nuts. So, yeah, far out. I've already recorded some footage, but basically we're moving, and we've got one project due right now, and then getting sick at the same time, everybody. So, what a challenge. Well, I've had bigger challenges in life, but that's another story.